Hey, and welcome to AUDIOTEK's 8th tutorial on Cubase 6.5. In this one, we will be looking at recording in Cubase and the different ways to go about it. For those of you who have followed those tutorials so far, let me start off by saying that things are about to get advanced in this one. And remember, you can always hit pause and rewind as many times as you want. If you are an advanced Cubase user already, I suggest you to follow along here as well, for tips on customizing automatic monitor enabling and for recording modes. I'll even put in some digital theory. In the previous tutorial on playback mechanics, I taught you all the fundamentals you need to understand, not only in order to find a workflow, but also in order to use things such as punch recording. And let's kick this one off with the very basics. I've already told you about the buttons on the track, such as the record and monitor enabler, and I've also told you about how to route your inputs properly according to your audio interface. So the 5 things you need to make sure is set correctly before recording on any track are: first, check and adjust your interface preamp until the signal is healthy. Second, check if your inputs is set correctly in the VST connections, and the shortcut is F4. Third, check if the right input is selected on the channel strip input. Fourth, check your input level in the mixer. And fifth, check if the track is record enabled. If you then go ahead and press record, any sound activity on the mic or line source connected to the selected input will be recorded onto the track. And of course, you can do this on as many tracks as your computer can handle at once. Again, check for a healthy signal, check your input connections and input levels, and remember to record enable the track. I already taught you about setting your input levels in the mixer, and you will almost never have to touch the input levels unless you intend your preamp to distort, and then dim the input level accordingly. So let me now demonstrate recording on 5 tracks at once. I'll go ahead and verify the inputs and make sure to record enable all of them. And notice when I press record how the record enabled tracks turns red. And this indicates that we are recording. You can also see the audio clips being generated in real time. And to finish up the recording, simply press stop. You can do this from the transport panel, but a much easier way is to simply hit the spacebar. And you can also record during playback, or stop recording without stopping playback. And let me demonstrate it. This time I'm gonna hit play. And whenever I feel like it, I can simply hit record. And as you can see, I'm now recording audio. And now to stop the recording, I can simply hit the record button once again to quit recording, but keep playing back. Let's take a look on loop recording. In the previous tutorial, you learned about the locators you place in the timeline to make up a cycle. When you are recording, you can use this for loop recording. It works just as you'd probably expect. You set your locators, turn on cycle in the transport panel, and hit record. With loop recording, the performer can do all the takes he or she needs until both of you are satisfied. You can even go in and take out things from each take and put together for one perfect take by using the lanes function that we'll delve into later in this tutorial series. And also in the transport panel, you have the option of deciding how clips on a loop recording is treated. Say you loop the same passage and record 3 takes. Would you like to keep all 3 or just the last one? I always keep all of them just in case, and the most recent will always be on top. And that's the default setting. If you would like to change it, click on the text Keep History in the upper left corner of the transport panel in order to change the setting. And if you would like to keep only the latest take from a loop recording, then click on Replace. But use this with caution and only when you surely know you only want the last take in a row. It can be useful combined with the punch recording mode, which I'll get to just in a minute, when you want to correct mistakes. In that case, you would set your locators around the point you want to correct. Set it to replace mode and press play while the musician plays along and hopefully corrects the mistake. And then you wouldn't have to worry about underlying clips, which can be an annoyance when you crossfade between clips. The cycle history and replace is very usable as well. And when you loop record in this mode, it will keep all the takes in that particular loop recording, but all clips underneath the new takes in the range of your locators will be deleted. So that's useful if you took a bunch of takes and then after listening them through, decided to go for another round. You wouldn't have to go delete the underlying clips first. Instead, Cubase does that for you. But again, I like having the option of going back to whatever clips I had before in case I regret it. So keep it on Keep History, unless you know you need to fix something. And next I'll speak a little about something called punching in and out. Punching in is a method of telling Cubase to automatically record on any record-enabled track during playback on a specified point. That's usable when you are recording a performance from the point the musician played a wrong note or a mistake. And now on digital we can always edit our clips afterwards and do crossfades and whatnot, but imagine in the old days with tape machines, how difficult replacing takes was. If you press record just a second too early, you could ruin the whole performance. So in many years, musicians have thrown out sentences such as "punch me in from the second half of the verse" and so forth. You can always simply punch in and out by hitting the record button during playback, but there's actually the option of letting Cubase do the key pressing for you. So in order to use the punch record mode in Cubase, you need to tell Cubase from where in the timeline you want to record. And in case you want the recording to stop on a later point in the timeline, you can tell Cubase to stop there as well. The easiest and most common way to set it up is simply setting up your locators in the timeline, and then opening the transport panel, shortcut F2. Here you're gonna be looking for the two buttons left of the playback buttons, labeled with two curves. One going from top to bottom, and one going from bottom to top. The upper one is for punching in, and the lower one is for punching out. Let me show you an example of simply punching in. I'm gonna check to see if my track is record enabled, and now I'm gonna enable punch in mode and press play from anywhere before my locators. See how Cubase started recording exactly at the point of the left locator. Now if I also want to punch out automatically, which is most often the case, I'll also click on the lower button to punch out. Now let's try recording again. And as you can see, Cubase stopped recording at the exact point of the right locator. Again, you could also just do this manually and then do your edits afterwards. But this is a neat way of making sure you only record exactly what you need. And also by default, Cubase records a buffer of 1 second before and after a punch recording. So if the first note was played just a few milliseconds before the point of the punch in, you can actually drag the clip start to the left and get that note. Very clever. And that wraps up punching in Cubase. Cubase can only play back one clip at a time on a track. So if you recorded several takes on top of each other on one track, the most recent one will take the on top position. And that basically means that's the one you hear when you press play. So if you right-click on such a bunch of audio clips on one track, you can decide which one you want to be on top. So to demonstrate, I'll hover my mouse above this bunch of clips in the project, and notice the lines going all across the clips on top. As you learned in the fourth tutorial, this means that there's clips below. If I right-click any clip, I can now go to Front and choose which clip I want on top. And now see how the clip I selected now is the one on top. On your Cubase installation, you might not get this panel when you right-click. Instead, you might get the toolbox. If you want to change this, go to the File menu, click Preferences, and look for the Tools tab under Editing. Here you can untick Pop-up Toolbox on right-click and hit OK. We'll talk more of recording later in this tutorial, but for now let's move on to something almost just as important: monitoring. There are two kinds of monitoring in Cubase. The first one is the internal Cubase monitoring, which I'll speak of first. Whenever you are recording, you probably want to listen to what's happening on the track. Of course, you can record without monitoring your recording, and then simply press play to listen afterwards. But I'm sure you'll agree that it's preferable to listen to whatever is happening on the track while you are recording. And Cubase gives you the option of turning monitoring on or off on a track, record enabled or not. You can find it on any audio track, and the icon is looking like a speaker facing to the right. When monitor is on, this button will have an orange shade. So here's the deal with monitoring in Cubase and all other similar programs. When you enable monitoring on a track, Cubase will only listen to whatever is happening on the input. And this means that with monitor on, even though there are audio clips on the track, you won't hear them doing playback. And this is because Cubase isn't listening to what's on the track. Instead, it is listening to whatever is happening on the input. So in times when you want to listen to your recordings and no sound is coming through your speakers, remember to check if the monitor button is enabled as part of your troubleshooting. So to sum this up, remember to enable monitoring when you want to record, and remember to turn it off when you want to listen to what you just recorded. Now on to one son of a bitch you will meet over and over again. Maybe you even tried this many times before, and maybe you even hit this tutorial up for this specific subject. I'm of course talking about latency. Now whenever you hit play to listen to anything in your project, Cubase will take a little bit of time, depending on your computer power, to calculate all tracks and plugins' relations to each other, in order to have it perfectly synchronized. In Cubase there is no such a thing as latency issues during playback, because of something called delay compensation. But when you record and want to monitor an input using the Cubase monitoring, there will be a slight delay between the actual sound is played or sung before it comes through your speakers. If your computer has lots of power, this delay can be so short that it's not even audible. But imagine having lots of tracks with lots of plugins on them. Eventually, even the most expensive of computers will start showing problems. It sounds like clicks and crackles and can be extremely frustrating. I mean, obviously we all want the latency to be as low as possible, but it does come at a cost of computer performance. And eventually you'll come to a point during a production when you have to increase the latency for everything to run smooth. And you do have the option of deciding how long the delay will be between the actual sound and the reproduction by adjusting the buffer size. Let me show you. Go to the Devices menu on top and open the Device Setup. Now go to VST Audio System. This is where you'll see your selected ASIO driver, the hardware sample rate, and the input and output latency. The sum of the input and output latency will be your overall latency, or put more simply, the delay between sound and reproduction. My current latency values are so low that no one would notice the delay. But if we come to a point where our computer can't handle anymore and starts clicking and crackling, we need to raise our latency by raising our buffer size. For this, click on the name of your interface ASIO driver, just below the VST Audio System tab. Now click Control Panel on the top to get to your interface-specific control panel. And mine will obviously look different than yours, but you should be looking for the buffer size settings or a slider in your control panel. I'm gonna raise my slider from the current 96 samples, which is extremely low, to 2048 samples, which results in a very audible latency. So if I now go back to the device setup and return to VST Audio System, check out how my latency is now much higher. But now, however, my computer works a lot faster and can manage lots of more plugins and tracks. So what do you do when you want to record and monitor, say, a singer onto a full production with lots of tracks and plugins? The singer will probably expect to be able to hear him or herself during the recording, but your computer or audio interface will not be able to handle low enough latency values. With any audio interface worth spending a few bucks on, there is a solution, and it's called direct monitoring, which is the second monitoring option you have in Cubase. Direct monitoring happens before Cubase. However, you do use Cubase for turning it on or off. What it will do is monitor an input with no latency whatsoever. And by this I mean at the speed of sound. And this is completely independent of the selected buffer size. It comes at the expense of not being able to listen to the input with the inserts you put on the track. And this is because the reproduction happens before Cubase, meaning that you'll get the raw sound of the input without any precious EQ, synth, or insert. But you can still adjust the volume using the track fader. You also turn the monitor on or off using the monitor enabler button on the track, just as with Cubase's own monitoring solution. Some audio interfaces comes with effects such as reverb, EQ, and compression on board, and can be used in the direct monitoring state. Steinberg's own interface, MR816CSX, comes with this, and that can be handy in situations when you need to go to direct monitoring mode and still give the performer some effects for a pleasant monitoring sound. In order to turn direct monitoring on or off, let's head to the Devices menu and go to Device Setup again. From here, go to the tab for your ASIO driver just below the VST Audio System. And if your audio interface supports direct monitoring, you can check the box to the left of the text Direct Monitoring and hit OK. And now every input you monitor will be monitored before effects or synths and with no latency whatsoever. But for now, let's leave direct monitoring off and head back to the project window. Alright, there are a lot of ways you can customize how Cubase turns monitoring on or off. And you can change this from the preferences, which I'll walk you through now. Go to the File menu and open Preferences. Now find VST almost in the bottom and click it. And here look for the box to the left of the text Auto Monitoring. If you click this, a list of different monitoring options will appear. Let me talk you through them. Manual means that it's entirely up to you to turn the monitor enabler on or off. And the advantage is that you'll always have full control of when you want to listen to the input and when you want to listen to what's on the track. The disadvantage is that it can be time consuming. And when you are running a session with this one enabled, you'll be turning monitor on or off all the time in between takes, especially when the musician is talking to you from his or her location in your studio. While record enabled means that any track that is record enabled will be monitor enabled as well. And this is very useful when you are having a recording session. Every record enabled track will be monitor enabled both during recording, playback and stop mode. But the disadvantage is that you have to manually turn off the monitor enabler when you want to listen to your recordings. While record running, we'll only turn on monitor on record enabled tracks when you are recording. So whenever you press stop, monitoring is turned off. And likewise, during playback, monitoring is off. And then tape machine style is the one I use. I think it suits a recording session the best. And this one turns monitoring on any record enabled track during recording and during stop mode. But whenever you press play, monitoring is turned off. So this lets both you and the performer listen to the input whenever he or she is playing or singing, and it also lets the two of you speak with each other in between takes. It's also very effective for punch recording. So now I think you're up to speed on the different ways you can go about recording and monitoring your tracks. You've learned how to record and you've learned when and how to monitor the inputs. But one thing we didn't yet touch upon is the more technical side of this. It's a very important aspect to know about, so I'm gonna speak a bit about it now. In the very first tutorial, I stated the importance of deciding for a sample rate and a bit resolution from the very start. I'll now speak just a bit about what those two things mean and why they are so important for you to know and consider. The sample rate determines the amount of samples taken of a sound per second to create a digital copy, measured in hertz. The higher the sample rate, the more accurate the digital copy of a sound can be. The standard sample rate for a CD quality is 44.1 kHz per second. And this will faithfully reproduce the frequencies up to just above 20 kHz. And that covers the human range of hearing. The higher your sample rate, the more accurate a digital representation of the sound can be through a greater frequency spectrum. Now remember, 44.1 kHz covers the full range of the human ear. So raising your sample rate won't make the difference in terms of great recordings. And whether or not there are benefits is a huge discussion that I won't cover. But what I will point out is this. You can record in as high a sample rate as your audio interface is capable of. But note that the file size doubles for each doubling of sample rate. And that means lower performance. I will add in an advanced lesson on digital theory and making your mix ready for mastering as one of the final tutorials, so don't worry too much about it just yet. And all this goes on in your analog to digital converter, which is probably placed inside your audio interface, unless you use an external ADDA converter in sync with your interface. But if you're not sitting in $1 million studio, your converter is probably placed within your audio interface. And on most audio interfaces, you can switch between different sample rates such as 44.1, 48, 88.2, and 96. And sometimes you can even go for 192, which I wouldn't recommend. It's very important that the active sample rate selected on your interface or converter is the same as the one you select in Cubase for that specific project. So to check this, first open the project menu on top and go to Project Setup. You could also use the keyboard shortcut Shift+S. In here, now check the active sample rate. If you want to record in 44.1 kHz, then make sure that it's selected in the project setup, and then make sure your audio interface runs at the same sample rate. And this can be changed from the control panel of your interface in device setup. One final thing on sample rates. You can always down or upscale any clip from one sample rate to another. So if you're sampling with 96 kHz per second in one project and want to import some samples in 44.1 kHz resolution, you can simply upscale those to 96 kHz without a problem. So that's sample rate. And if it's too much right now, just keep your sample rate on 44.1 kHz always, for the time being at least, and don't worry about it. And next up is bit depth, which is just as important. Now, if you imagine sample rate as relating to the digital copy's accuracy of the sound's frequency spectrum, imagine the bit depth as the digital copy's accuracy of the sound's dynamic spectrum. And I know this is a bit complicated, but in terms of digital audio reproduction, the bit depth determines the precision of the sound's dynamic levels. Working with higher bit depth will also capture a wider range of harmonics that would otherwise be too quiet to capture. It will also make the signal louder before distortion, giving you greater headroom and thus lower noise. And the standard CD quality bit depth is 16 bits. I'd recommend you always to record and mix in at least a 24-bit resolution. This gives you the possibility of mixing and recording very quiet sources without losing sound quality. So what you need to take with you from this right now in terms of bit depth is this. The higher the bit depth, the greater accuracy of dynamics, more volume and less digital noise. To change this, open the project setup once again and select either 24 bits or 32 bits. And this setting is only made in Cubase, so you won't have to change anything in your audio interface control panel. And now I think we can go back to recording some music. But the reason why I put this thing in this tutorial is always be concerned about setting the correct sample rate and bit depth for a project. So for a good base to work from, set your bit depth to 24 bits or 32-bit float point mode and keep it that way. One final thing I want to add in this tutorial goes for your input channels. So let's head back into the mixer, and the shortcut is F3. Not only can you change the levels of your input channels as I've showed you previously, but you can also put inserts on your inputs, such as EQ or compression. So if I add an EQ to input channel 1, all my EQ changes will be recorded along with the audio onto a track. And in by far the most cases, you want the option of putting your plugins on the track after the recording in order to keep the raw sound intact. But as you can see, you do have the option of adding plugins before the sound gets placed on a track in your project. But if you want to do this, I'd recommend you to set the bit depth to a 32-bit float point mode of technical reasons. Basically, that'll ensure no added distortion to your recordings. The input meters will by default show the input level after your plugins and pans. Imagine you put a compressor on the input track and then gained the volume a lot. And obviously the volume of the input would be louder then, right? Yeah. And if you want your input meters to show the input volume values before your added plugins, you need to change the meter mode to meter input. So here's how to do it. Simply right-click in the gray space of the mixer and go to Global Meter Settings. From here you can select Meter Input. Now, even though you have raised your input volume, let's say 30 dBFS with a plugin, your input meter will still show the raw input volume from before any added plugins. And in the top of our channel strip, we can raise or lower the input gain before plugins and before the channel fader. So this gives us the option of adjusting how much signal we want to feed our plugins with, and then we can use the fader at the bottom to adjust how much signal we want to send onto a track in Cubase. So once again, I'll repeat myself. In by far the most cases, you will not have to consider this. If you just leave the input volume at 0 dB and leave the insert strip empty, you will be just fine. I'm gonna go ahead and change the meter view back to post panner, which is the default. Okay, let's close the mixer with the shortcut F3. I know there is a lot to take in here. If you feel like you're not ready to move on just yet, I suggest you try putting some of the things I taught you in this one to use on your own. Try recording something, get experience with the different recording modes, find out how you like your monitoring, and so forth. And whenever you feel like it, let's move on to the next one. So thanks for your time, and I'll see you soon.